The last section that we are going to talk about deals with a concept called partial pressure. There's no real equation here. The concept is pretty straightforward. The idea is that imagine you have two different containers. The container that I'm circling here on the left has some gas in it. I guess they are saying that it's helium gas if you look carefully here. So there's helium gas in this container, and the pressure from the helium gas is 2 atmospheres. And imagine you have a separate container. This has a different gas in it. Looks like it's argon over here. And the pressure caused by the gas in this container is more. It's 4 atmospheres. What the concept of partial pressure says that is if you could merge these two containers, but not alter the pressure of each individual gas. In other words, the pressure of the helium was still 2 atmospheres and the pressure of the argon was 4 atmospheres. If you could merge the two containers, maybe you could connect them in some way, that the new pressure caused by both of these gases together is just the sum of each individual pressure. In other words, if you could merge the two containers on the left into the one on the right, the new pressure would be 2 atmospheres plus 4 atmospheres. So the new pressure here would be 6 atmospheres. And it doesn't really matter how many gases you have. You could merge 10 different gases with 10 different individual pressures, and the new pressure would just be the sum of all of the individual pressures. And those individual pressures are sometimes called partial pressures, which is where the concept gets its name. So if you mix 2 or more gases, each has its own pressure, but the new pressure, once you mix all of the gases together, is the sum of all of the individual pressures. And there's a problem on the next slide, which is pretty straightforward. You can pause at any point to try to figure out the answer. The question says a scuba tank is filled with something called trimix, which is, I guess, a breathing gas mixture for deep sea diving. The tank contains oxygen with a partial pressure of 20 atmospheres, nitrogen with a partial pressure of 40 atmospheres, and helium with a partial pressure of 140 atmospheres. What's the total pressure in the breathing mixture? You can pause if you want. Basically, the total pressure is just the sum of all of the individual pressures. So it's 140 plus 40, which is 180 atmospheres, plus another 20 atmospheres. So the total pressure in the scuba tank is 200 atmospheres of pressure. And that's it for partial pressure, and that's pretty much it for the unit. This was a pretty short unit. I realize that you have an exam this week. I'm also not going to do a lab this week, so there isn't a whole lot conceptually to soak in except for the formulas. There will be no quiz this week, although the quiz in the subsequent unit will basically include the information from this unit. So next week we will do Chapter 9, and the quiz will be on Chapters 6 and 9 together. So just to conclude, you don't need to memorize any of the formulas. I would give those to you on a quiz or a test. You do, however, be able to need to use the formulas that we discussed in this unit. So as far as Chapter 6 conclusions are concerned, there are a handful of equations that let us figure out the temperature, pressure, and volume of gases under different environmental conditions. Boyle's law basically says what happens when I alter the pressure or the volume of a gas in a container. Charles's law says what happens when I alter the volume or the temperature. Combined gas law says what happens when I alter pressure, volume, or temperature. And Avogadro's law says what happens when I alter the amount of a gas in a container, what happens to the volume. And that's it for Chapter 6. So good luck on your exam.